Okay, chapter 8 is on sinusoidal functions, so looking at sine and cosine. I apologize in advance, I've got a little bit of laryngitis going on. So the first section that we're looking at here is just a bit of a review on angles and angle measurements from what you've done in previous math courses. So when we're dealing with sinusoidal functions, we use radians instead of degrees most of the time when we're dealing with this. So the radian is just the measure of the central angle of a circle. It's attended by an arc that is the same length as the radius of the circle. So when you're dealing with radians, this measurement of this C to A will be the same distance as the arc that is made by it when it's attended from the central angle. So the radian then is the measure of that central angle when we have these qualities. So when our radius and our arc are the same, then we're looking at a radian measurement. So angles can be measured using different units. These includes degrees, radians, gradients, and minutes and seconds. Any angle measures represented as real numbers without units are considered to be in radians. So if you see 23, and we're talking about angles, that means that this is in radians, as opposed to the little degree symbol. So units of measurement for angles. Degrees was devised in ancient Babylon, and one complete rotation requires 360 degrees. Gradients was devised in the 18th century, and that is where one complete rotation is equal to 400 gradients. On your calculators, you have that GRAD button or mode. That's what that's for. And then radians was devised by mathematicians and scientists, where one complete rotation is equal to 2 pi. So we have our circle here, and I'm going to try to center this as best as we can. So when we're dealing with radians, hopefully it'll be fairly accurate. Well, I'm off already. Okay. So if we know that this is the radius, then this is the radius. And the length of this, maybe this will be a little more. The length of this, oh, darn it. And the length of that are equivalent to the length of that arc. But if we do a little bit of reshaping, this, to change my color, we could stretch out, we flattened it out, would be there. And then this, that would give you approximately a equilateral triangle. So theta is equal to 1 radian, and 1 radian is the equivalent of 57.296 degrees. So this little double squiggle that means approximate. So 2 pi radians then is equal to 6.28 radians, because 2 times pi is 3.14, and 2 pi gets us all the way around the circle. So 2 pi radians is equal to, and a value is 6.28 radians, which is equal to 360 degrees. So pi radians then is about 3.14 radians, which is 180 degrees. Okay, doing our conversions, and we did this in I think Foundations and Pre-Calc 20. So relating degrees to radians in a circle. So if we put degrees in green, and we'll call radians in red, if you want to figure out if you do whatever your degree is over 360 degrees, that is the same as saying how many radians out of 2 pi, because 360 is equivalent to 2 pi. So then if we want to calculate just for d, d would be equal to 360 degrees times r, so all I'm doing here is cross multiplying over 2 pi, which means that your degrees, if I reduce, is equal to 180 degrees divided by r over pi, because 2 will go into your 360. So if you want to figure out how many degrees are in something, and you want it in radians, then you do 180 r over pi. So radians, on the other hand, if I do the same thing, do my cross multiply, I would have r is equal to 2 pi times d over 360 degrees. So that means r is equal to, because my 2 and my 360 will cancel, pi d over 180 degrees. So basically what we're saying here then is 180 degrees is equal to pi radians. So we know that, whoops, I better change. We know 180 degrees is equal to pi radians. So then we either use, to do our converting, 180 over pi, or pi over 180, depending on which way you want to go. So if you want radians, if you want to find your r, you're going to do 180 over pi. Sorry, if you want to find your degrees. If you want to find your radians, you do pi over 180. And the way I usually remember this is, what am I trying to get rid of? And if I'm trying to find radians, then that means I need to get rid of my degrees. So I need to have my degrees in the bottom to divide out by. So calculate the value of each angle in radian measured to the nearest tenth, and then sketch each. So 100 over 1. So again, I want to get rid of my degrees, so I need my degrees in the bottom. So this is 100 pi over 180. So if I multiply and divide, that leaves me with 1.7 radians, or 1.7 rads. If I were to make my quadrants on here, ,90 degrees is here, so 100 degrees is just going to be a little bit off, so it'll be going to, say, there. Whoops. So this is my 1.7 rad. So 290 degrees. So I multiply that by pi over 180, I get 290 pi divided by 180, which is equal to 5.1 rads. Oops. Turn that off. So 290. Just going to be a little bit past the 270 here. So this would be 5.1 rads. Okay, my last one, 590 degrees. So that's 590 pi over 180. So that leaves me with 10.3 rads. So if I draw that, oops, a little high. So I know 2 pi rads is equal, or 2 pi is equal to my 6.28 radians. So I know I'm going more than once around the circle. I have to go one plus almost half, not quite. Sorry, a little bit more than half. So if I do it in degrees or radians, it doesn't really matter. All the way around is going to give me 300 and, oops, I should do that in my other color. So all the way around gives me 360. Another 90 degrees gives me, oops, I went a little, oh well. Might as well do it to, was my sliver off. So to there, 360 and 180 is 540. And I need another 50 degrees. So a little bit more than half. Oh, I'll have to fix my alignment. So that is 590 degrees approximately. So that is my 10.3 rads. Okay, example 3 says calculate the value of each in degree measurement to the nearest degree and then sketch each angle. So I'm in rads and I want to be in degrees. So I need to get rid of my rads, so that means I have to put the radians in the bottom. So 5.79696 times 180 divided by pi. So that leaves me with 331 degrees when I round it to the nearest degree. So 331 degrees is almost all the way around. It's about to there. So that's my 1 degrees. 0.7854. So that is approximately 45 degrees. So 45 is pretty close, halfway. 14.8353 times 180 over pi. So when I multiply that, I get 850 degrees. So 360 twice is 720. And then I need another 130 on top of that. So I'm going around once, twice, and then I need 130. So about there. Oops. Okay, that was bad. So that is 850 degrees. So it says for example 4 says for each pair of angles determine which measure is greater. So 3 pi radians or 8 radians. So 3 pi radians, that's the same as saying 3 times 3.14, which is about 9.42 rads. So 3 pi would be greater than 8 rads. 3 pi rads, I guess. 400 degrees or 6.5 radians. So I have to convert one or the other. So I'll just convert my 6.5. Oops. I did that the wrong way because I want to keep my 180 so that my pi goes on the bottom. So that is equal to 372 degrees. So 400 degrees is greater than 6.5 rads. Okay, so that's what you do to compare those. And that's all for this section.